Welcome, folks. My name is Mark Carlson. We also have Eric Hibbard here, and we are going to talk about the state of cloud security. So, standard legal notice from SNIA, and my picture, as well as Eric's picture, since you won't see us on screen otherwise. And I'm Principal Engineer at Industry Standards at Toshiba. I chair the SNIA Technical Council, as well as the Cloud Storage and Object Drive Twig, one of the original authors of the CDMI spec, which is now an ISO standard. Eric is the CTO of Security and Privacy at Hitachi Data Systems. He co-chairs the Security Twig, the Cloud Security Alliance. He's the Vice Chairman of the American Bar Association Cloud Committee. He's an ISO editor on numerous specs, and he's the chairman-elect of Insight's TC CS1 Cybersecurity, as well as the IEEE Security and Privacy Standards Committee. So with that out of the way, let me just talk briefly about SNIA. We have currently 160 unique member companies, 2,500 active contributing members, and over 50,000 IT end users and storage pros worldwide. So our agenda today will be a summary of the standards development organizations, what work is going on in cloud concepts, CDMI, and SLA framework, and cloud security and privacy. We'll talk about securing the cloud supply chain and then get into emerging and related technologies. So without further ado, let me give you Eric Hibbard. Go ahead, Eric.
Thank you, Mark. And let's see here. All right, so I'm going to start off to in the world of standardization. SDOs stand for Standards Development Organizations. The cloud space has many actors, and so if you are trying to find the one standard that rules them all, good luck. That's really not going to be the case. On this little diagram, you'll notice that there's towards the center ISO, IEC, SE27, and then to its right is SE38. These two organizations play fairly important roles. SE38 actually deals with cloud computing in a generic sense. SE27 deals with security techniques, and also that means security as well as privacy. And so it also covers cloud as well as other technologies. These two, so ISO and IEC, are two standards organizations recognized by the World Trade Organization, which is why these two are important. The third organization that also is recognized by the WTO is ITU-T. And as you can see, there's an interrelationship between these three standards development organizations, and they've actually collaborated on a range of ISO standards. We'll talk a little more about a few of those. But then you'll see that there are organizations that are interacting. So you see things like the Cloud Security Alliance, you see NISA, you see the Trusted Computing Group, IEEE. Many national bodies are working with ISO. So in the case of the United States, Insight's Technical Committee CS1 is what we call the Mirror Committee dealing with security for SE27. And, oops, I see I've got a mistake here. Insight's Cloud 38, there was a renaming, is the U.S. Mirror Committee for SE38. So lots of players. Storage Network Industry Association is actually working with both the U.S. as well as some of the ISO activities as well. So moving to specific standards that are effectively relevant. So if you're interested in the cloud computing standards, and even a little further the security aspects of that, these will show you some of those key documents. It also shows you that there's some interesting interactions between these various documents. Kind of at the core, we have the ISO IEC 17788, which is the think of that as the vocabulary and sort of basic concepts. So if you're looking for a definition in cloud computing, that would be the document that you go to. 17789 is a reference architecture for ISO, and this is actually also an ITUT document. So this is where the three WTO recognized standards development organizations have collaborated and come up with common vocabulary, so terminology, as well as some of the key concepts. Moving out from there, you'll see that towards the top, where there's kind of a purplish color, there's 27040, which deals with storage security, and inside of it, it deals with cloud storage. 27018 deals with privacy kind of activities. 27017 deals with controls for cloud that sort of expand beyond 27001, which is the standard that many organizations use for their security checklists. And then 19086, which shows up in sort of the purple as well as kind of the gray. It's a multi-part standard that deals with cloud service level agreements, and it's in a sort of framework, multi-part, so it deals with concepts and metrics and core requirements, and that's parts 1, 2, and 3 respectively. Part 4 is dealing with security and privacy. And there's several others. I would then draw your attention to the far left. The 17826 is CDMI, and Mark is going to talk a little more about that. We're going to use that as an example or a use case of sort of talk through the kinds of things that you'll see in the cloud space. And probably the newest work item is ISO IEC 22123. So that's on the far left. That's essentially building on the original 17788, which was more focused on vocabulary and some key concepts. This one's an expansion, so building on top of what was in 17788. So on top of those activities, there are several other groups, as you know, I mentioned a few of these already, that operate in the cloud space, and it's important to be aware of their activities. So the IETF is a huge player. Essentially the internet standards are basically coming out of the IETF, and so some of the work that they've done is crucial to cloud. For example, SSL and TLS, which are the ways many of the communications are secured. You'll hear RESTful interfaces, which is basically HTTP. Well, the security for that is done by TLS, and the IETF specifies that. NIST is a National Institute of Standards and Technology, is a U.S. government entity, produces lots of guidance standards for the U.S. government, but because they're free, they're often leveraged by the private sector as well. But if you're doing business with the U.S. government, their documents are things that you have to pay a lot of attention to. NIST does a lot of work with ISO and to a lesser degree ITUT, but mainly ISO, some of the committees that we already mentioned. You'll see in a little bit some of the work that SNIA does, the Storage Network Industry Association. Oasis has got several specifications that operate in the cloud space and are relevant. The Trusted Computing Group is worrying about how do you do roots of trust in, for example, virtualization and how that applies to the cloud. Cloud Security Alliance, as its name implies, is very focused on cloud security and was one of the early organizations to send up sort of warnings of things that you should be worrying about. They've got an assortment of documents, something on the order of 30 different working groups that are operating in this space and related technologies. Open Group is another activity, as is the DMTFs, that have specifications that may be relevant to your activities. But as you can see, a large number of groups that are working in this space, and lots of moving parts. And anybody that's worrying about security in the cloud effectively has to be aware of many of these activities to have a comprehensive sort of view and approach on what they're doing. So I'm going to transition to Mark here to use CDMI as a use case to explore some of the cloud security kinds of things that you may encounter. Mark, take it away.
Great. Well, so the Cloud Data Management Interface from the SNIA, as Eric mentioned, is now a international standard. It's called something different, of course. ISO IEC 17826:2016. SNIA manages that standard and submits it to the ISO JTC1 organization on a periodic basis to update it. So it's a RESTful HTTP. But perhaps it goes beyond some of the proprietary standards such as Amazon S3 and OpenStack Swift, in that it really standardizes the management of your data once you get it into the cloud. And there's all sorts of data services that are typically used in the storage industry for dedicated storage systems that are only now making their way up into the cloud services. Things like archiving, data retention, being able to put an administrative hold on any deletes of objects. Those kind of things are capabilities that we envision clouds offering in the future. So we've standardized the way to actually request a given level of service from the cloud and measure how well that service level is being achieved. So that's the CDMI standard. And we have some interoperable data security goals for the standard. We want to be able to store data in a sort of semi-trusted cloud storage environment. What I mean by semi-trusted is, the customer is forced, in some cases, to trust the cloud provider, and almost always the provider does not trust the client. And so that sort of determines some of the capabilities that are possible for securing your data in the cloud. We really want to address the interoperability of medical records with backwards compatibility to some of the existing interfaces that are out there. This is a huge use case that we want to be able to address with cloud storage, that people are a little wary of putting their medical records in the clouds right now. So part of that is having the capabilities such that they can trust it for their medical records. We'll use encryption where possible. It's a technique. It's not an end goal. Encryption is used to secure things, whether it's keys or actual data. That's just one of the techniques that we use. Centralized key management and ID management. This is to ease the burden of encrypting in all these different places and needing a key for each encryption step, etc. you really want to have a key management service that you use in conjunction with your cloud provider or even on-premises cloud environment. We want to support consistent policies. We want to support auditing and access control. And we want the possibility for so-called break-the-glass procedures. And what we mean by that is a doctor, perhaps in a foreign country, is trying to get your medical records in a life-threatening situation. Well, how does he get those medical records? It's sort of like a fire alarm where you break the glass and pull the pin. You want to be able to override some of the security protections in a life-threatening manner, where perhaps even the patient is unresponsive to provide you with the authorization to do the medical procedures. So within the SNIA Cloud Technical Working Group, we're working on a couple of extensions. What we mean by extension is it's a separate document that's a companion to the CDMI standard. And the reason we do this is so that we can understand if this is a popular feature, popular enough to need an interoperable extension or feature added to CDMI. So what we do is we put these extensions out there, we get people to implement them, and when we get multiple implementations that actually interoperate, then we add it to the next version of CDMI. So the encrypted object extension makes a cloud object server sort of encryption aware. So the server side of that can do in-place encryption and decryption. Alternately, the client can do the encryption or decryption. And the whole idea here is that the keys are stored by an external key management service, which really simplifies the management of all these keys that you're going to need if you want to do this correctly. And the extension itself is completely transparent and compatible with the regular CDMI, so essentially any object can be sort of encrypted or decrypted by the server, and that's on an object-by-object basis. Now, the second extension is called our Delegated Access Control extension, and it gives control of the access decisions back to the data owner. So this could be the patient with their medical record in the cloud. The patient has control over who can see their medical records. So that can be implemented actually either on the client or the server. It can be used to deliver cryptographic keys to somebody that wants to decrypt your medical records, for example. And it can be used with any HTTP-based storage protocol, including Amazon S3 and OpenStack Swift. So here's a use case, right? Over on the left, we've got, in the upper corner, we've got an MD, a doctor, right? And he's got an identity management server in his location, and he's got in his hospital a CDMI client that can contact the hospital controller, which is a CDMI server. That server also interacts with the patient down below. The patient will also have a CDMI client, and that would be a patient interface to CDMI. And then the hospital CDMI server also has access to a key management server, which is the key vault here down on the bottom. So there is a cloud, let's say, in France. The patient is in France. The doctor is in France. And so the medical record is not yet, perhaps, in the French cloud. It's in a USA cloud, Cloud B, or it's maybe even in the cloud at Hospital B, which is where the patient perhaps created that medical record, or the patient's doctor created that. So The creation of the medical record on the hospital computer needs to be done by the French doctor. The the patient themselves has to sign a consent on the hospital CDMI client that says, yes, this doctor can see my medical records. And then the Cloud A is responsible for the cloud storage of these encrypted records for that hospital. And the original request is going to come into the hospital B for those medical records. And the original author of the medical record is responsible for the policy enforcement and auditing of who accessed that medical record. And then the last thing is this key vault here is the secure place to store the cryptographic keys. That's optional, but you really want to have that if you're managing multiple patients and their cryptographic keys. And then Cloud B here is responsible for local replication of encrypted records. And again, you don't need, you can have as many clouds between point A and point B as you like. And then in the hospital A, he's a stateless gateway, essentially, responsible for doing the encryption and decryption once it lands, that data lands at that hospital A. There. So those are all the roles, and what our encrypted object extensions, the two extensions working together, sort of allow this use case to be done. We've been working with Philips, a Netherlands company, and they have a business wrapped around these medical records, and that's why they've been helping us improve CDMI for this kind of a use case. So this is a real-world use case where we're trying to use the cloud to handle security and privacy. So the encryption is built on top of the state-of-the-art JSON object signing encryption. This is another standard. SNIA does not create this standard. It's a widely used internet standard. So for object encryption, the authenticated content is encrypted via AES GCM. We allow either symmetric or asymmetric key wrapping, and those are the standards there for that. For authentication, object authentication, we can use either message authentication code, HMAC, or digital signatures, RSA or ECDSA. And then delegated access control provides negotiated encryption tunnels using above primitives, right? And allows you to do mutual authentication via X509 certificates. And this is this is something that nearly all cloud interfaces use. Swift uses it, S3 uses it. So that's all these standards are pretty standard. There's open source code you can go get. And there is an alternative mode where you can get compatibility with content management systems or other approaches. So here's some references. We did a couple of Bright Talk webcasts on this already. You can look at it more or less user-oriented Bright Talk webcasts here in the links. The slides here will be available. And we'll put that in the questions. I think, if not, go to SNIA.org, look for the Cloud Bright Talk webcast. There's also more developer-oriented webcasts that we did. It's an MP4 file. It's called Developing Interoperable Cloud Encryption and Access Control. The slides are available as well. There's a CDMI website. You can download the CDMI specification. There's a white paper on this specific healthcare use case. And then there's a link to where we have these actual, extensions. And then for the JSON object signing and encryption, or JOSI as it's affectionately called, there's 3 different specifications that are referenced there. Okay, I'm going to turn it back now to Eric, and he's going to take over from here.
Okay, thanks, Mark. So we're going to talk a little bit about the issue of the supply chain, and in particular around cloud. As many organizations are increasingly concerned about how their various suppliers and the suppliers to them, and there's this chain, if you will, that is an issue that we've found from a security perspective, problems with code being injected where it shouldn't be injected, in an assortment of issues. From a storage perspective, when we look at hyperscalers, large customers, this is an area where there's an increasing set of issues. Looking at drive vendors having large orders to these customers, the features they want are very different. We're seeing, in the case of software-defined storage, that again, some of the feature set that's needed in this space, can take advantage of what some of the hyperscaler techniques can use. So we're seeing on the storage side a need for certain functionality and certain security capabilities, and at the base level, that then sort of trickles up through the overall supply chain of the IT infrastructure. Talking a little more about the hyperscale infrastructure for drives, we're seeing the software handles data availability and is resilient to component failures. So there's no single point of failure in the storage systems, and this as storage is sort of the heart and soul for a lot of our infrastructure. This is actually helping. The basic model has been direct attached storage, or DAS as we sometimes refer to it, with basically CPU, which covers memory and I/O, and size to servicing the needs of however many drives of what type can fit into a rack or tray or two. So some of the larger systems can have a couple thousand drives, for example. And these hyperscales go way beyond those kinds of capabilities. So if you think of traditional enterprise class storage, these hyperscale infrastructures significantly dwarf what you can see in more traditional storage technology. We've got high-speed interfaces, PCI and NVMe. We're now using SSDs off of the motherboards to increase the speed on this technology. And then there's custom data center monitoring and management to basically monitor all these components. So many of these components are from a wide range of vendors. And so from a supply chain perspective, how all these components come together in these hyperscale infrastructures is definitely an area of concern. So when looking at the various suppliers and worrying about the security, unless the drives can be confidentially erased, they have to be shredded, or said another way, if you can't clear them with technology like, for example, overwrites or cryptographic erasure, then you actually have to do destruction, which is, for an organization, can be a fairly expensive proposition and require special handling in the media and things of that nature. The data path protocols of choice are TCP/IP or PCIe. A preferred SAS and SATA are widely deployed for direct attach. Hyperscalers secure their own management path infrastructure, and software-defined storage layers also implement standard securable interfaces. And the SDS, that's often we'll see things like TLS is where that comes into play. All right, I'd like to talk a little generically about outsourcing to the cloud. If you're not aware, there's actually a standard. It's a multi-part standard, 27036. And basically what 27036 does is it provides guidance on outsourcing in general. Part 4 talks specifically about dealing with cloud, and as you can see, it takes advantage of a fairly large number of standards, some of which we've already talked about, and its intention is to help cloud service providers understand what kinds of issues consumers of cloud technology may need to have handled in some fashion. And it covers networking, it covers software, incident response, storage security, information security management, and protection of PII or privacy. So if supply chain security is one of the areas of concern that you have, then 27036 is probably a family of standards that you should take a look at. And in fact, I've seen entire presentations that have been dedicated just to the issue of supply chain security and then how cloud kind of fits into that. But there historically have been many concerns about using cloud, and so understanding the risks, the threats that may exist. The 27036 standard goes into identifying what those are, and then offers guidance in terms of how you can basically address those. And you may find that that's a handy tool to sort of understand your own needs, your own environments. As a cloud service provider, it will help you understand what kind of security controls you potentially have to address customer needs as well. So it's usable from both perspectives, if you will. Another standard that is a bit of a work in progress at the moment, although it's parts of it have already been published, is the 19086. So this standard deals with cloud service level agreement framework. It's particularly interesting because when it's completed, you'll actually have the ability. So if you're a cloud service provider, you'll have the ability to benchmark your SLA that you're using for your business against the standard to actually determine whether you've got all the right components covered in some fashion. And as you can see here, these are major sort of categories of guidance, if you will, that need to be addressed in some fashion. So you see information security is a component of the SLA framework, but it also covers things like performance and availability, accessibility, cloud service support, termination of service. It turns out this is an area that is particularly important in certain jurisdictions. So we're seeing with some of the changes in the European Union's General Data Protection Regulation, which goes into effect May of 2018, termination of service is something from a cloud perspective that's going to become very, very important. Historically, from an outsourcing perspective, the termination clause is actually considered one of the most important. Unfortunately, it's usually one that's given the least attention until fairly late in the process. Also covered is governance and service changes, service reliability, attestation certifications, data management, and then PII protection, or depending on where you're at, that may come under sort of a privacy heading. So all of these elements are actually discussed in, this is a multi-part standard. So part one outlines the concepts. So it's very useful in the sense that it gives you some basic background. As a consumer of cloud, it's a handy tool to make sure you're asking all the right questions. Did you, when you were looking at a cloud service provider, did you think about what kind of performance issues that you need to have addressed or available, or any one of these things? So it's a good mechanism to check to make sure that when you're contracting with a cloud service provider or you're signing up for a service, are you getting everything you're going to need? Part two, which is not published yet, is dealing with metrics. And so metrics as to how they would relate to each one of these content areas that you see on the screen right now. Part three deals with core requirements. So this is the part of the standard that you can actually look for specifics. And in this case, because it's conformance, it actually uses the term shall, which in the standards world is important, because that's how you can term it. It sets a minimum bar that you need to have addressed. So if you're looking at a service level agreement, and it's making a statement as to it conforms to 19086 in some fashion, then that gives you an indication that they've gone in and looked at the specifics laid out in particular in part three. Part four deals with security and privacy. That document is not published at the moment. It's probably about a year away. Part three, the core requirements that I just mentioned, is actually in the publication process right now. So if this is an area that you're interested in, I would definitely encourage you to take a look at the 19086. Even the part one, which basically covers concepts, is a very useful document. The American Bar Association is quite excited about this standard because it actually covers materials that sort of can be leveraged in sort of the contract space. It doesn't intrude in that arena, but it covers many facets that may not be covered by the contract. So the combination of the SLA and the actual contract should give you the full range of coverage you need. Another topic that comes up with supply chain security is the issue of cloud security certifications. And as it stands right now, basically there's two that are commonly referred to. One of them is FedRAMP, So this is a U.S. government program that, and as a government program, it takes advantage of government standards. So in this case, one of the NIST standards is Special Publication 800-53 and Revision 4 of that standard. This is basically all the security controls. It's comparable to the 27001 and 27002 standard from ISO, but it is unique to the U.S. government. Very thorough process. It takes quite a bit of time. So any cloud service provider that's providing cloud services to the government typically has to go through the FedRAMP program. It means they've been subjected to pretty significant review, and of course the reason they're doing that is they need to convince the U.S. government that they've got their act together from a security perspective. What's important to note is that the U.S. government, as relative to countries like in Europe or Japan, Australia, Singapore, for example, that are very focused on privacy, the U.S. government doesn't have the same privacy focus, and so that may be an issue if you're outside of the U.S. An alternative is something that the Cloud Security Alliance has set up, and it's the Security Trust and Assurance Registry, or STAR. They have a certification program. It's got multiple levels. Level 1 is self-assessment. So, and by the way, you need to pay attention to these levels because in the case of a self-assessment, it basically means you've, as a vendor or a cloud service provider, have gone through and said, yep, I do all these things, and I'm claiming I do all these things. Many security people like myself, we hail from Missouri, and it's, prove it. And that's where level 2 comes into play. You've got a third party coming in and doing the assessments. And in that particular case, you end up actually doing a 27001 certification, for example, as a starting point, and then you go into some of the cloud-specific things that come from the Cloud Security Alliance. And then a third, which is continuous monitoring based, is one of the newer mechanisms that CSA has come up with. It's not clear if they've actually got anybody operating in this space at the moment. They have a lot of people, a lot of organizations that are doing level 1, smaller set that are doing level 2, and the level 3 is fairly new. The criteria that are used are the Cloud Controls Matrix, which is something that if you've been operating in the cloud security space for a while, odds are you've actually taken a look at it. And the CAKE, or the Consensus Assessment Initiative Questionnaire, is the specific requirements above and beyond, for example, the normal sort of security requirements in 27001. So these two are, if you're looking to see what kind of review a cloud service provider has gone through, these are two that you can take a look at and focus on. Okay. So I think with that, what I'd like to do is switch gears a little bit, and it's not all about just cloud. It turns out cloud is being leveraged, or the intention is to leverage cloud in a bunch of different areas, and as you can see here, well, everything's playing nice. Well, what that means is, as we move into some of these areas, or these emerging technology areas, or we're expanding on the use of the cloud, what kinds of things are we going to encounter? And I see I have a header issue here. So one of these that comes up on a regular basis is multi-tenancy versus secure multi-tenancy. And I'll tell you that multi-tenancy is think of it from a security perspective as we've done with classical sort of web servers. So you can actually have one physical server that may offer up hundreds or maybe even thousands of what appear to be separate web domains. But they're actually all on a single server, and through the magic of DNS and other technologies, they all coexist on one server. That is your typical multi-tenancy kind of scenario. Cloud is kind of tracking in a similar fashion. The issue of security, how much separation, actual separation you have between, in the case of web, between those various domains, or in the case of cloud, the various tenants, it can actually be fairly limited. And as we've seen, there have been numerous instances with vendors, for example, in the case of Amazon, where a simple misconfiguration can expose multiple tenants when only one tenant should have been exposed, for example. So this is a situation where multi-tenancy, the actual security separation, can be somewhat limited. Secure multi-tenancy is a different animal, and it basically there are not very many instances that are true secure multi-tenancy at the moment. The basic concept behind it is that the security is as good as if each of the tenants was on a separate piece of hardware. And that's a tall order to meet. It also means that the security infrastructure for each tenant can be handled. So, for example, if you've got Active Directory and key management and authentication and logging, each one of the tenants in a secure multi-tenants environment would be able to access and leverage their security infrastructure. It would be completely separate from the other tenants. So it does represent an extreme. What we're seeing over time is that many of the cloud service providers have moved from a very primitive multi-tenancy scenario from a security perspective and are moving closer and closer to secure multi-tenancy. So they're adding access control and support for all this infrastructure. But it's very important to understand when you're engaging cloud service providers, what exactly you're getting and how do they keep the tenant separate, especially if you are putting up sensitive information on the cloud. In terms of standards in this space, the only standard that I'm aware of at the moment is 27040, which is the storage security standard. It has some descriptive language in that standard that talks about secure multi-tenancy, but short of that, there's not much else that I've seen that actually defines what it is. So the next area that I wanted to touch on is virtualizations and containers. What I find quite fascinating right now, at least in the standard space, is that there are very few standards that are actually covering the topic of virtualization. The reason I find it fascinating is the cloud, for the most part, is very dependent on virtualization technology. So in the absence of actual standards covering virtualization, that means that you're not likely to see standards that also address security as it applies to virtualization. A little bit of work has started in SC27, which is the ISO committee that deals with IT security techniques. but that work has only been underway for about a year or so. Containers, at this point, I'm not aware of anything that's actually in the standard space. So what that means is you're down to seeing documentation from particular sources, Docker and whatnot, but it's not necessarily gone through rigorous review by the security community. So this is a particular area cloud is dependent on. However, not much has basically been specified in terms of guidance or actual requirements. And it's important to know that because if there are issues with the underlying virtualization, that may in fact be the source of certain data breaches or exposures to worry about. So it's a good thing to be asking your cloud service provider how they're dealing with these two issues. Yes, the next topic I'd like to just briefly mention is big data and analytics. There are lots of instances where combination of using cloud is kind of a sort of central clearinghouse, if you will, around data is kind of an ideal setting. I mean, you're creating a repository, if you will, that makes it easy to then turn around and use big data and analytic techniques. And many organizations are beginning to do this. We are seeing, for example, in the standardization space, in the case of big data, we're seeing reference architectures being developed. We're seeing terminology being developed, concepts, kinds of things being developed. There's even a standard covering security and privacy has been initiated. But from a standards perspective, very early days. We're talking maybe a year and a half into the development of the standards. And in terms of an ISO standard, it typically takes 3 to 4 years once a project is basically approved. So we're looking at a situation right now where it's probably another year to year and a half before we actually start seeing standards in this arena. In the case of big data, NIST has produced some materials, and it's definitely being leveraged by the international community at this point. Again, it's one of the few works that cover the topic as well as looking at some of the security and privacy issues. The next one is IoT. This is and related technologies sort of refers to things like smart cities that may be leveraging IoT. Again, this is an area where we've got numerous organizations looking at IoT. For example, the Industrial Internet Consortium has actually produced a security guidance document, at least for the industrial side. But if you look for actual standards, what's being developed right now covers things, again, reference architectures and concepts, and nothing in the security and privacy space. And in fact, there's an expectation that by the end of this calendar year, we may see the first security and privacy project in ISO will be initiated. ITUT has done some work in this space, but it tends to be fairly abstract. If you're looking for sort of just general concepts, then there's some materials that have been published in that arena. But if you're looking for something fairly specific, so you're thinking about either doing something with IoT or you're a vendor that's operating in this space, the guidance is fairly thin at the moment. One other area that it's not listed here that I probably should mention is the concept of federation. And again, from a cloud perspective, this is something that's been talked about quite a bit. What we haven't seen, again, are standards in this space, and I'm aware of some activities that are starting up within the IEEE that will be working in conjunction with NIST. So this will cover, basic concepts behind what is federation, trying to establish, vocabulary. Goal is for federation to work, of course, you've got the issues around interoperability. And a major portion of federation is around security. So things like federated key management, federated identity management, and some of these concepts exist outside of the cloud space, but we're now beginning to see an interest in bringing these into the cloud arena and figuring out how they will work in conjunction with cloud. That's the good news. The bad news is we're just now beginning to look at some of this, so it means it's going to be a while before we actually see standards in this space. So that means in all of these cases, because the standards are either non-existent or in their infancy, by and large, you're going to see more proprietary, one-off kinds of solutions. And that's not necessarily bad, but it's important to note that at some point, when these standards emerge, if these are areas that you're interested in, you're probably going to ask about how they'll transition to deal with those kinds of technology areas. Okay, so just checking the slides, it looks like there was a question, how can we get the slides? And Diane has answered that they will be available, and a URL has been provided.
That's this URL, I think, right here.
Yeah, that's right. So what we'd like to, so this is a kind of a wrap up of what we wanted to present today. We would like you to please rate this webcast. We truly do value your feedback. The webcast is available on demand on the SNIA Cloud Storage website, the URL listed here. Questions answered from this webcast will be included. So if you've asked questions and we didn't answer them, although at the moment I think we've answered all of the one question that has come in, and yes, these slides will be available. And of course, we'd like to thank you. I'd also like to draw your attention to, if you do go look at these standards, we did rattle off, or I did in particular, a bunch of numbers, and that's the problem with being a standards geek. So there's a list of these standards and their actual titles of many of the ones that were mentioned here. So if you're interested in some of the documents that I referred to, these are the actual documents. Unfortunately, most of these will cost money. The exception would be if you see something from ITUT, you can get those documents for free. But for the most part, the ISO standards do cost money, and unfortunately, that's just the way it is. But there are a lot of good materials in those documents. So I think with that, I'll check to see if we've got any more questions. Here we go. Is there any generic cloud security certification independent of the vendor? So the answer to that is yes, FedRAMP in the U.S. government and the Cloud Security Alliance STAR program. Those are both independent from the vendor. I guess what are the major cloud security certifications? Those would be the two. Next question is cloud storage the velocity is bandwidth. Please recommend someone velocity. I'm Not sure.
I'm not parsing that question either. But there's two orientations for cloud storage. One is how fast can you get your data, and that's the bandwidth. And then how long does it take to get that first byte of data, and that's the latency. And so latency is obviously dependent upon how far away you are from the cloud service provider. The bandwidth is, what are the network connections between you and the provider, and that's also out of the hands of the cloud provider as well. So, unless you want to rephrase your question, that's my answer.
Okay. So the next question is.
Go ahead.
Oh, go ahead. Are the CSA
you're the CSI guy. Yeah.
Internationally recognized. The answer to that is yes. The CSA are internationally recognized, and right now, to my knowledge, it's the only one that's actually trying to be international. Part of that recognition is using the ISO 27001 certification at its core. So that's an important component of it. The one area that if you're truly thinking about international, you might want to pay attention to is that in China they've not adopted the latest version of the 27001 standard. And so the certifications, the CSA STAR certifications being done in China may not be the same that are being done in the rest of the world. And that's maybe one detail to pay attention to.
All right. Well, I think that's all the time we have, and that's all the questions we have. So thank you guys for participating. This will be available as a recording, also on that same website back here. So this SNIA.org/forum/knowledge/webcast, and each one of those has a little click there you can go to find the slides and to find the recorded video from today. Thank you, everybody, for attending, and look forward to our next webcast. Bye now.
All right. Thank you. All right. Bye now.